is I try to like personify the series. So I want to kind of like set the stage for that a little bit. I want to say that we as a group, hopefully you can commit to this. We're going to be like cheering for the series to converge. We want them to converge. I mean, mathematically, we don't really care. But let's just say we're cheering, like these series are trying really hard to converge. They want to. Sometimes they do, and sometimes they don't. But we're cheering for them to converge, right?
You can't cheer until it converges at 10. That's what Logan said.
Okay. Well, we'll see how that turns out.
Oh, that's fair community.
So if you remember last time, what we did is we found a bunch of partial sums. And I basically said, hey, let's work on your intuition. Does it look like this series is going to converge? And in one case you said, yeah, it kind of looks like it. And the other one you said, no, I don't think that would converge. So obviously it's going to be inexact and take forever to do that sort of exercise every time. And so we're going to be looking at different types of series and different ways to deal with those as far as the convergence or divergence of them. So today we're going to look at 2 ways that we can do this, okay? And in the coming weeks, we'll look at a lot more than just the 2 ways. And last time I told you I was going to introduce you to the mean coach and the fair coach. And these kind of go with our 2 tests that we're going to be looking at today. So the nth term test is the first one. And again, we're just trying to personify this just to hopefully maybe get it to stick in your mind a little bit. So the nth term test. Have you ever, those of you that have been in athletics or maybe arts or something where someone's trying to coach you in something, have you ever had a coach that when you did exactly what you were supposed to do and you did it well, the coach was basically just silent? They didn't say good job, they didn't encourage you, they just were expected you to do it great, and when you did it great, they're just like
That's my dad.
silent. They didn't really say anything, right? So this is like the tough coach, right? And some of us, I will say this, some of us need a tough coach. Some of us maybe don't as much, right? So the nth term test is like this really tough coach. So, and we'll get into the details here in a second, but essentially the nth term test, if a series is definitely going to converge to a real number, the nth term test says nothing. It doesn't tell us anything, it doesn't give us any information about that. It's silent. However, if the nth term test shows that the series is going to diverge, the nth term test will shout it from the rooftop. So this is that tough coach who, if you do it great, they don't say anything. But if you mess up, they're going to tell you that. They might yell at you even. That makes sense? That's the nth term test. If the series is going to converge to a real number, silence. If the series is going to diverge, it'll yell it out loud. That's the only thing it can do. So sometimes in some books, this test is called the divergence test because it will only tell you if a series diverges. It didn't tell you anything about convergence. So here it is. We've actually started to kind of look at this. I know I wrote this out once or twice the other day. Here it is. If you take the limit as n goes towards infinity, so we're talking about the longest of long-term behavior. Limit as n goes towards infinity of a sub n, and that would be that little nth term that was in the sigma. If you do that and you don't get 0, if you get anything other than 0, then the series you're looking at diverges. And this is that example we looked at last time. Remember, I think the nth term was like 3 plus 1 over 2 to the n. Remember how I said at the end it would essentially be plus 3, plus 3, plus 3, plus 3 forever? That'd be an example where the nth term wasn't 0. And your intuition said, I think that would diverge. The nth term test would say it for sure diverges because that nth term is not heading towards 0. It's got to be specifically heading towards 0. You could look at a graph of this. Maybe we've looked at a few graphs of these. This might help a little bit. So if you have a series that, I'll just put little dots here. So like if the first term is there, next term, and it seems to be leveling off at a number that's not 0, then in the end, wouldn't you be adding a bunch of numbers that are not 0? Okay, so that would mean you'd get a diverging. It would tell you for sure diverging. Where this one falls short, where this one falls silent, is if you have a series and you test out the long-term behavior of the nth term, and you see that the nth term behavior goes from here to here to here, and it seems to be cozying up to 0. You can see that from my purple graph there. What does the nth term test tell us? Nothing.
Doesn't diverge.
Well, if it doesn't diverge, then it converges, right? It's just silent. It doesn't say anything. Because if I told you, hey, there's a series and it doesn't diverge, what's the only logical conclusion? It converges.
Can it approach 0 and still diverge?
Correct. It's possible. Do you remember when we did improper integrals?
Yeah.
And there was a series of questions where I said, wow, look at this and look at that. And this one seems like it would still converge, but it didn't. And I said something about it has to do with how fast the terms are heading towards 0, or how fast the graph is heading towards 0. We're coming back around to that. Yeah.
So that this test isn't always, just because it goes to 0, it doesn't really mean much.
It means nothing.
Yeah.
Remember, that's when, so if you do the limit as n goes towards infinity of your nth term and you do get 0, that means the nth term test told you nothing.
Okay. So
And that would mean you'd have to move on to a different test to get a complete answer.
So you never really know when you're right unless it's just wrong.
Yeah, you never know what's going to happen unless you get the limit as n goes towards infinity of a sub n is 5. Something other than 0. Yeah, something other than 0. So I wrote down there that the inverse of this is not necessarily true, right? So we can't reverse it and say, hey, look, the nth terms are heading towards 0, therefore this series must converge. That could be true or it could be false. We'd have to do further analysis to figure that out. So there at the bottom I sum it up saying, essentially this test can only identify series that diverge. It's not going to identify a series that converges. We'd have to do more work. Probably just one more step, but more work to get there. Okay, so the nth term test is the really tough, really mean coach. It'll only tell you if you're messing up, and it won't say anything if you're doing it great. Okay? The geometric series test is a little bit more of a fair coach. So the geometric series test, and this is one that you probably saw in pre-calc. Geometric series test will tell you if a series converges. It'll tell you if a series diverges. It'll tell you both ways. So it's a little more fair, right? If the series is doing the wrong thing by diverging, it'll tell the series. The series is doing the right thing by converging, it'll say that too. So it's a little more of a fair coach. It'll say great job if you're doing a great job, or not very good job if you're doing a terrible job, right? The only problem with the geometric series test is it has a very, very limited scope. Okay? So this coach can only, like this would be like the defensive backs coach on a football team. Like they can only coach the guy that's supposed to cover the other team's receivers. They can't coach anything else. They're very good at what they do, but their scope is very limited, right? That would be like if I was going to coach the basketball team and I said, you know what, I can only coach the point guard. That's it. I don't know what to tell the center. I don't know what to tell the forward. I could tell the point guard what I think they should do, but that's it. So they're a very good coach, very fair coach perhaps, very limited scope. What's the limited scope here? It'll only tell you stuff about geometric series.
It's like the Atlanta Hawks. They only have a guard.
Yeah. And it's like you're really good at one thing, and you're really good at it, but don't try to get me to do this with something else, right? You would never be able to use the geometric series test on a series that's not a geometric series. It's very limited. Later on, we're going to see some other coaches or tests here that are very good and have a much broader scope where they might be a little more versatile, if that makes sense. So, like I said, this is hopefully something you saw in pre-calculus. A geometric series is of the form a plus ar, a times r, plus a times r squared, plus a times r cubed, so on and so forth. A is the first term, and r is what we call the common ratio. So this is when you multiply by something to get the next term, right? So if I said 1 plus 1/3 plus 1/9 plus 1/27 plus 1/81, what's my common ratio? 1/3, right? So that's what these are. And so like I said, you probably saw these in like Algebra 2 or Pre-Calculus or maybe both classes. This is what a geometric series is. And here is the geometric series test. It really hinges on one thing. Can you identify r? So the fact that some of you said, I think the r is 1/3 with what I just did, that's a good sign. If you can identify the r, then you'll know. So if the absolute value of r is bigger than or equal to 1, then you're going to get a diverging geometric series. If that same absolute value is between 0 and 1, then you're going to get a converging series. Okay? And this is the one time all year, all unit long, that if we do get a converging series, we can actually find the sum of the series. The rest of the time, it's just going to be diverges or converges. But in this case, maybe you remember from pre-calc, there's that lovely little formula down here, putting it in a green box, where it says the sum of that geometric series is equal to A over 1 minus R. Again, maybe you saw this in pre-calc. I hope you did. If you didn't, it's really not that hard of a formula. It's first term over 1 minus R, and that's it. Okay, so we can actually find these sums. Most of the other ones, we're not going to be able to directly find the sums. Okay, so like I told you yesterday, you have just met two of our math coaches. The nth term test, also known as the divergence test, and the geometric series test. And we're going to try to use these here a little bit. So the real challenge with these is identifying when to use what test. Now, there's only two of them right now, so it's going to be like one of the two. But if you can imagine later on, if there was like a third or a fourth or a fifth or a sixth, ... it becomes a little more difficult. So I'm going to try to point out the key elements that tell you that we should be using this test or using that test. Okay. All right. So here we go. So number one, I'll probably be a little bit all over the place here, so just bear with me. So number one, this is one, like once you get a little more seasoned, this is not going to take you long at all. And maybe already it doesn't take you very long, I don't know. But maybe on number one, you would think about the nth term test, perhaps. So if I did this, I would say the limit as n goes towards infinity of 2 to the n. And I'm trying to do the nth term test, right? And what happens when I try to do this? What do I get? 2 to the huge number, you get a huge number, right? So this equals infinity. And what's the most important thing about that? Say again? It's not zero. So some of the notation here is ultra crucial. You need to put that. You need to say, hey, I calculated this limit, and I got this infinity thing, or whatever you got. You need to relate that to zero. That's what tells us what we need to conclude here. So since that limit isn't zero, we can say, therefore, and I'm okay if you just put the series. There's only one series in there. I know what you're talking about. Therefore, the series diverges. Maybe you approached it that way. Did you notice also that this is a geometric series, right? It's a to the n. So maybe you didn't see it the way that I just saw it. Maybe you thought to yourself, hey, the series that we're looking at there is geometric. And what's the common ratio? 2, isn't it? Somebody just said that? Yeah, the common ratio is 2. So, and R equals 2. Therefore, the absolute value of R is greater than or equal to 1. And if that common ratio's absolute value is bigger than 1, like in this case, what's the conclusion? Yeah, the terms in the series are just getting bigger and bigger. So we can say, therefore, the series diverges. So this is one where you really could have used either one of these two tests that we just looked at. You could have used the nth term test, no problem. You could have used the geometric series test. So some other little notations here. You could put nth term test down here. So like on your quizzes and stuff coming up, since you're just like learning this, I want to make sure that you know the terminology so that we're all speaking the same language. I would want you to like label what your thinking was, right? Like give me the name of the reasoning you used. This other one, the geometric series test, if you just wanted to put GST, standing for geometric series test, GST is something that just about everybody recognizes in the math world. We would know what you were talking about there, but I will have you try to label those, right? I'm not going to just have you say the reasoning. For now, later on we'll probably loosen that up quite a bit, but for now I just want to see if you know what it is that you're talking about. Yes, sir.
If we recognize that it's a geometric right away, do we have to go through the nth term test first?
No, but I just wanted to show you two avenues that would have worked there. Yeah. Either way is fine. Any other questions? Okay. So then number two. Number two obviously is a little bit more complex. I'm going to zoom a little bit here. Okay, so I am gonna roam around with this one a little bit here too. Before I get roaming around too terribly far, do you see the simplifications that could and really should be done?
Yeah, the plus 2.
That plus 2. What could I do with the plus 2?
You can hold on.
Yeah, we can. We can kind of get it out of there, and we can get it out of there kind of in stages. So I'll go 2 to the n over 5 to the n. Oops. 5 to the n times 5 squared, right? If you're adding your exponents, you're really multiplying your bases. And Jack, I think what you were referring to is like getting it completely out, right? And that's what we really ought to do here. So this would be 1/25 sigma from 0 to infinity of 2 to the n over 5 to the n.
So we can treat that like we can treat it in like a derivative.
Absolutely, yep. Yeah, because remember the sigma just means sum, and so whether you're multiplying by 1/25 on the inside of the sum or multiplying after everything's already been summed, you should get the same thing. There's one more piece of the puzzle here. Anybody have an idea what we could do with the 2 to the n over 5 to the n?
Can we just do
Just make it 2/5.
2/5, all to the n, right? So I would write it like this. This will hopefully help us later on keep some things or get some things clear. So it'd be 2/5 to the n. Okay, so the 1/25, if we're going to find the sum, the 1/25 will matter. The 1/25 is not going to affect the convergence or divergence of this. What's going to be the main factor as to whether this will converge or diverge?
R.
The R. What did you say? The common ratio. So did you guys recognize that this is a geometric series? Okay, so let me say this. Let's say that you were doing this. Let's say this was number 5 on a quiz or something.
Excuse me, could you have Nick Solomeni come down to the front desk with his car keys, please?
Dun, dun, dun.
Oh, come on. Did I not put in my sticker? Dang it. I think I'm going to because I'm not.
Nick is on his way.
Where'd you park? I'm in a handicap spot, but I'm allowed to because I have my sticker. But I don't sticker
So they're going to make... Why does he have a handicap? It was because his leg?
Knee surgery.
So he's going to have to walk all the way down there on his bad knee. Bummer. Okay, anyways, let's say you were doing this on a quiz and you thought, I'm going to do the nth term test. Because you thought that's a good place to start. So if you did the nth term test, you'd say limit as n goes towards infinity. And you would just handle the nth term there. You'd say 2/5 to the n. And you thought this through, and I'd be okay if you just kind of reasoned to this. If you think about what's going to happen here, isn't this essentially going to be 2/5 times 2/5 times 2/5 times 2/5 times 2/5?
So it's going to be
So what are we heading
a
towards?
pretty big number over a way bigger number.
So heading towards 0, right? Heading towards 0. So this is an exponential, right, with a fractional base. So you might look at this and say, hey, I'm excited because I did the nth term test and I got 0. Therefore, that means nothing. Wasn't exactly a complete waste of time, but as far as getting to an answer, it kind of was, right? It's not going to really tell us anything of what we're trying to go for. So I'm hoping then that if you were doing a question like this, and this is what I'm talking about, like experience and seasoning will matter, and you guys are already showing that you have this, I'm hoping that you would look at that nth term and say it's geometric. It's not that hard right now because there's only 2 possibilities, and one of them is geometric, right? Later on, it'll be a little bit harder to do that. So I'm hoping that you would recognize that it's geometric, and you wouldn't even try this. You just skip over that right away and say it's geometric. I'll just do that instead. So geometric series, you want to say this. The series is geometric. So you want to identify it and say I've figured out what it is I'm dealing with. And what's the common ratio? 2/5. Therefore,
Between 0 and 1.
the common ratio is absolute value is between 0 and 1. Another way to write that, of course, is you could write, I'll put it right here. You could write -1 is less than r, which is less than 1. That's also very acceptable. If you just got rid of the absolute values, it's saying the exact same thing. Up to you. Basically means it's a fraction between -1 and 1. Either way will work fine. Okay, so because of that relationship of r to the 0 and the 1, we can say, therefore, the series converges. And this did ask us, I think, to actually find the sum if we can. I can't remember if that's what the instruction said, but we'll go ahead and find the sum. We know that the sum exists, and with geometric series, we can actually find it. That was insanely fast, Nick. You just tell him?
Rochelle Miller here, so I should just talk to her.
Thanks for being fast. Sorry you had to go down there. Okay, so now you can say this. You can say this series does converge. And not only does it converge, we know exactly to what number it'll converge. It's a, which is the first term, over 1 minus r. So what would be my... You got to think about the 125th here, right? What would be my first term? Because we start at 0, wouldn't it be 125th times 1? So it would be 125th. So my first term is 125th over 1 minus the common ratio of 2/5. So it would be 125th over 3/5, which is 125th times 5/3. So I'm getting 1/15. Make sense?
Yeah.
Okay.
Are we gonna get clapped for not simplifying?
Clapped.
I don't know if that's the term you guys use over there at college. Are
Clapped.
we gonna lose
Yeah.
points for not simplifying? Because I said 5/75ths and then they like.
Totally fine with that. Totally fine. Totally fine.
So we do have
Do
to
10 150ths if you want.
So we do have to show that after we show
It's like
the
in
series
there, like,
conversion.
So it will, so in a,
Get clowned.
only with a geometric series would anyone ever ask you, at least in this class, to find the sum. But to be honest with you, Logan, if all the instructions said, and I can't remember exactly what I wrote for the instructions, if all the instructions said was, does the series converge or diverge? You don't even have to do what I did in black.
So that doesn't, okay.
Determine convergence
Yeah.
or divergence.
Yeah, so I like in class, I'm going to take some license and say, what if it said, what's the sum? But yeah, on a quiz or a test or something, if it didn't explicitly say, and the sum is, because I got to be honest with you, if a question ever says, hey, does the series converge or diverge, and what is the sum, if it does, what are we talking about? A geometric series, right? It's kind of giving it away, perhaps, and maybe that's okay, maybe it's not, but, you know, maybe it'd be a thing I'd ask. But you just want to just follow the instructions.
Could we just, I mean, we could really just find the sum with the nth test, right? If
Nth term test?
yeah,
What do you mean?
If we know for a fact that like if it diverges, doesn't, or I guess.
At that point, you'd say the sum doesn't exist, right?
Yeah.
Yeah.
I'm tripping.
Yeah, so I mean, I guess you could say that you could make a conclusion about the sum, but you couldn't say what the sum is. Yeah. Okay, why don't you guys take a minute and see what you can do with numbers 3 and 4. Please work on, like if you're working on this and you're trying to prove something converges or diverges, please do work on actually writing it out. Because I'm sure you've been at that place before where it sounds really good in your head, you start writing it, and all of a sudden it sounds terrible when you're writing it. So practice writing it, okay? So have at it. Numbers 3 and 4, please.
I think I've got an idea for number 3.
Mhm.
And I feel like I'm cheating, but at the same time, so
Definitely want to get the 3 out, yep.
yeah, two to the n with a 1 there. Could I justify that that's also a 1 to the n?
Yes.
Okay.
Yep, no problem.
Great.
You certainly can. That's not cheating at all. Meg?
So I think what he said, I put my hair, but do you think we could clear out the
You should definitely get the 3 out.
I just want to make sure.
And the key there is noticing then, obviously when you get 3 out, the leftover would be a 1. So 1 over 2 to the n could be rewritten as 1/2 quantity to the n.
Wait, was one of that always just be 1?
That make sense?
Yeah, I was like, well, why couldn't you do it with 3 then?
Because then that would make a huge
Right,
difference,
I know
because the
it
3 really isn't
That's what I
to
was
the
like, it
n.
would matter.
The 1 is unique, right?
Now we,
So
now I
do we
got
even
it.
have to simplify this to use the nth term test?
I don't think, to be honest with you, on number 3, I don't even think I personally would bother with the nth term test. I would look at this and I'd say, hey, look, the numerator's constant, and the denominator is geometric, right?
Never mind.
So I would just instantly know that the limit's heading towards 0, which tells me, like you said, nothing. I would just jump to geometric right away. That's why I say, like, get a little seasoning experience, which you guys all have enough of that right now. I would just go there. I wouldn't bother with the nth term. So working on 3 and 4. Give you a couple more moments here with 3 to try to get things sorted out. I think I will we'll probably save the ball drop one. I don't know. We'll see where we go.
I thought I used the ball drop one.
It's a good one. Yeah, it's definitely a good one. Well, we'll see where we get here. I'm actually going to have you guys keep your loop quizzes. There's no like copyrighted material on these, and I'm phasing this one out. So I'm going to let you keep them.
Wait, are we supposed to do 4 and 5 as well?
Just try 4 as well. I'm just looking around, just hoping people will work their way towards the finish of 3. But if you got time, work on 4. And you can look at 5 as well. That's not a problem. I think 3, 4, and 5 are all very similar. Some good repetition, good practice.
In what situations would I feel like I could almost like simplify everything, take coefficients out and do things in a way to where I can almost always use the geometric test.
Oh, gotcha. Well,
is it wrong that I'm just not seeing any
So-
term tests?
well, I think you could apply the nth term test to all these,
Right.
honestly. And in some cases, it would tell you something. In other cases, it would tell you nothing. The nth term test really potentially applies to every series you'll do. Geometric, of course, only geometric.
I guess okay. So if n is in like anything other than an exponent, then we have to use the nth term test essentially.
Well, there's going to be other tests later on too. So later on, we're
Right,
going to
right.
use the integral test, the p-test, comparison test, limit comparison test, alternating series test,
Yeah.
ratio test, etc. Right? So we're going to build out all these other tests for different forms.
Yeah.
What if there's factorials in there? Oh my gosh! Remember we saw factorials, so geometric wouldn't work there.
Or if there's like just like 2n plus 1, then I can't.
Totally, yes, right, there
Really?
you go. So that would be like, and there's a harmonic test too, it'd probably be a harmonic.
So essentially n has to be an exponent for us to work through the geometric. Okay.
Numerical base, variable exponent. Yep.
Great.
Okay, let's look at number 3. I did pull the common factor of 3 out just to clear things up. And then, Meg, this is where I kind of dropped you off, where we had this 1/2 to the n thing going on.
Yep.
So the hope here is that you would at this point recognize that the nth term test would point us right towards 0, which is not going to tell us anything. Then you'd be able to then secondly say, hey, look, it's a numerical base with a variable exponent, therefore it's geometric. And so I can use the geometric series test. So you'd want to identify that. You'd say the series is geometric, and common ratio is 1/2. Therefore, the common ratio is between 0 and 1. Therefore, the series converges. And the reasoning there would be the GST. And if you were asked to take it one step further and actually find the sum, we would say that the sum is... Let's see here. The first term would be, what, 3? Over 1 minus 1/2. Sure, that's 3 over 1/2, which is 6. Sam, I think you got it. Okay. Number 4 then, you see how number 4 has that one extra 3? Is it? Yeah, 3 hanging out in there. 3 to the n plus 1. So again, you guys are all like super capable. I'm hoping that eventually you'd get to this where in one step you would go 3 is out, 3/4 to the n is the summation element. And if you take two, 3 steps to get there, I have no problem with that. But I'm just hoping for your own sake, time-wise, you can say, all right, factor out the extra 3, big parentheses around the fraction to the n. Make sense? So hopefully in your head only you would say, all right, nth term, heading towards 0. Not going to tell me anything. And I've got a numerical base. I'll write this up here. Numerical base, variable, exponent. If you see that, if it's just that, numerical base, variable, exponent, we're talking about a geometric series, right? That's exactly right. So you come over here and you'd say the series is geometric. Julia, what's your common ratio? Say again? 3/4. Okay. So this is where it's super important. Like sometimes people get tempted to just like stop there and say, cool, R is 3/4, therefore the series converges. So if I did this, obviously my conclusion is correct, right? But my reasoning is incomplete. So somebody could read this and say, oh, I get it. Whenever the common ratio is 3/4, the series converges. It's like, well, it's more than just that, right? So you want to identify what is it about the 3/4 that's so important. So instead of concluding right there, you would say, therefore, that common ratio is between 0 and 1. You could even put 3/4 in there instead of the, like if you wanted to write this, be okay with this, right? I need you.
R equals 3/4.
Yeah, identify it. Say, hey, the common ratio, like R, we'll all take that R to mean the common ratio, but tell me how it relates with 1, essentially, right? Tell me how it relates with 1, and then you can make your conclusion. So you say, therefore, the series converges. Because I just used the geometric series test. So don't just name the R. Tell me what it is about the R that's telling you what you need to know.
What's the difference between when n equals 0 and n equals 1?
So technically,
Because
so
when I was looking at like the nth term, I noticed that you used like that example or like the equation you put as n equals 1, whereas the geometric series test is 0.
It could go either way.
Does it matter?
So like that lower.
So what does it mean
It
then?
means that it starts at 0 or starts at 1.
Exactly. So you're either going to plug a 0 in for n at the start or a 1 in for n at the start, and that would potentially affect the end sum. Like, if it's actually going to sum to something, that's going to change what the end sum will be, but it will not affect the convergence or the divergence.
So will we have to be able to like write this the sigma notation? Like, when will we have how will we determine? Will we have to determine whether it's n equals 0 or n equals 1, or will we?
Totally, and I'm flexible on that. There's no one right answer.
Really? So it just changes the sum, obviously. Is that what you're saying?
Well, so if you were going to write a full series, right?
Yeah.
The series should have a single sum, right? If I decided to start my series at 0, and you decided to start yours at 2 for some reason, then our little element in the sigma would change, right? It would be like, instead of like something to the n, it would be something to the n minus 2,
Okay.
right? So I should be like, if we're supposed to come up with a particular nth term for a series, I should be able to plug in your numbers, and I should be able to plug in my numbers,
Oh,
starting at 0 or 2 or whatever we started at, and get the same thing.
So you just adjust it based on.
Yeah, you just do a little phase shift in your n.
So how will I know whether to pick?
Just like, look at how much work could I put in this.
How to pick what?
Like whether it is how will I determine that between the?
Well, I mean, most of them, it makes sense to start at 0 or 1.
Okay.
Just like do a test, test it out. Say, all right, if I plug in a 0 and then go 1, 2, 3, what's going to happen? And if that's what you want it to be, you're done. You like it, you're like, whoa, no, there's like an extra term in there. I need to do something. Start it at 1 or something.
Okay.
Yeah.
Fair
Don't stress about that too much. We'll get into like that series writing stuff in the latter half of this unit.
enough.
Okay. Anybody notice anything about number 5?
It starts with that.
Starts at 1 too, that's a good point. Good point. Starts at 1.
Yeah, it starts at 1. What else do you notice about
That
it?
good old 1/3 there hiding.
We do have an extra 1/3, so maybe we do this. We go 1/3 sigma from n equals 1 to infinity. What would be the leftovers in there if I did get that 1/3 out?
5/3 quantity to the end.
Yeah, 5/3 to the n. Anything strike you there that might be
It's larger than one.
Don't get tripped up. It's still larger.
greater than 1? Okay, so could I use the nth term test, or do I have to use the geometric series test? You actually could go either way. You could. If you found that nth term, you would get the thing. Actually, this is what we started our set with here. We'd get infinity, which isn't 0. So you could say, therefore, the series diverges because of the nth term test. Or you could say the series is geometric and r equals 5/3. And the absolute value of 5/3, of course, is bigger than or equal to, because or equal to also causes divergence. 1 there. Therefore, the series diverges. Reasoning is the GST. So you could go either way there. Make sense?
So if it diverges, we don't have to do the geometric one, we can just use the
Totally. Yeah, so if you get a conclusion from the nth term, you're done.
Okay.
If you don't, then you got to move on to something else. In this case, for us at this point, the only other something else is geometric series.
Okay.
You don't have to write GST for number 4.
I probably should have. So yeah. Sorry if I don't do that consistently, because I usually don't do that consistently. I'm just saying early on here, like on your quiz, I'm going to say something like, hey, does the following series converge or diverge? State your reasoning, and I'm going to say name what test you used. I'll put that in the instructions, because I want you, because again, you're just like beginning out here. I want to make sure that you're like, oh, here's my reasoning, and I even know what it's called. I think that'd be a good place to be. Okay, so, man, I'm so debating about this. I'll tell you what, let's do this. I'll hand back your loop quizzes, and you can look at those, and maybe we can kind of do the ball exercise here in a minute as well. So, and you, like I said, you guys can keep these. These are not going to be reused, so enjoy. Hey, there you go. Harvest anymore. There you go. Have a look. There you go.
A lot of them are on phones.
No peeking.
All right, lobes.
And I had to get some. So you learned that.
There you go. Julia.
Wait, maybe that was my phone.
5, 6, 7 were the most commonly missed, for sure.
Oh, I missed 5, 6, 8.
I missed all of
Oh, wait, Jenny, I missed some of those.
Yeah, I missed all those too.
5, 6,